Hi there everyone, this is Dave here. I thought I would do a video or a couple of videos on my proposed upgrade to my WorkBee CNC machine, or more specifically the controller. I'll do a little bit of background first to explain why I'm proposing to upgrade the controller or change the controller. So at the moment I've got two milling machines. The first one I bought, which was years ago, was this little fella here. This is a Sable2015 small, obviously, as you can see, small milling machine. Its little tabletop here is not much big, well, about the same size as an A4 sheet of paper, but it's extremely well made. It's all aluminium construction. It weighs a ton for its size. Lead screw on all axes, double linear rail on all axes. Really lovely machine, and it's yeah, it's great. The only thing that's possibly a slight limitation is its spindle. It's got a very nice spindle with four bearings in it, driven from just a simple DC motor and then a two-speed pulley system, which gives you sort of 4,500 and about 9,000, 8,000, 9,000 RPM, something like that. But I've used it a lot. I used it for milling brass, making printed circuit boards for electronics. I built a little tray in here where I could submerge glass and mill glass using burr bits. So I've used it a lot. It's a really nice machine. If I had something small to mill, I'd always use this one first. The pitch on the screws is really small as well, so it's really accurate. But then, you know, as time went on, I got a bit of a taste for milling and decided I wanted to sort of mill larger things, mainly sort of wood, you know, making usual stuff, you know, cutting boards, tabletops, that sort of stuff. So I invested in this guy, which is a 1 meter square WorkBee, not sourced from the normal UK outlet. I actually got it from a guy in Belgium, and it yeah, it's been great. Had no problem with the actual milling machine hardware. I have had it was supplied with an X controller or X-carve controller, whatever you want to call it, which is a USB based control. It's easy just to show you. It's this. It's lovely made. I mean, I got no problem with the build quality. It was superb. Really nice aluminium extruded case. It's got so you've got a power supply at the bottom, usual kind of switch mode, 24 volt, 14, 15 amp supply, whatever it is. This is the main circuit board, main control board. The stepper motor controllers are the ever popular TB6600. There's 4 of them because the WorkBee's got 2 motors on the y-axis, so you need two drivers in tandem to drive the 2 motors. But effectively, it's a 3-axis controller. But the guts of it, the brain of it, if you like, is this little sort of chewing gum sized board here, which is effectively an Arduino platform using the MACH3 XHC microcontroller, which is a very capable microcontroller. Well, it's capable of flying quadcopters in real time, so it's not going to have too much problems here. And it's on like a little board with you know, with a 40-pin dual inline footprint that plugs into a chip socket, so it's kind of cool. And you've got USB one side, and then these pins are whatever you want them to be. In this particular application, they're generally speaking general purpose I/O, so inputs and outputs, pulse pins, direction pins used to drive over optical isolation. These are the optical isolators used to drive the stepper motor drivers. So that's basically what it does, what it works. So there's a USB cable here with a little short one. I put this in with a noise suppression choke, and then back to the front panel standard USB socket. Right, I'll put it down, it's heavy. So the idea is you plug that into the PC over the USB. The Arduino exposes itself to the PC as a COM port, which is just a serial connection. I can't remember what speed it uses. I think it's like 115k baud, something like that. Pretty standard. And then on the PC you'd be running control software. So I was using Universal G-Code Sender, which is extremely popular. And so basically, as the name suggests, universal G-code sender streams G-code over the COM port, over the USB, to the Arduino, which is running GBRL firmware, which is again very popular and sort of fairly standard. That firmware interprets the G-code and then basically turns it into GPIO activity, which is direction pins, pulse pins, and returns limit switch information back up the serial interface to the universal G-code sender. That's how it works. Now the problem I've got is not with the problem I've got is with the USB connection, and it's not just me. I mean the internet, or the forums are littered with people that are having USB connectivity problems, and they all sort of are similar in nature. The way it manifests itself is that the USB connection just disconnects, so the Arduino will just drop off and you just lose the connection. And what happens then, it could be 5 minutes into a job or 5 hours into a job or anywhere in between, and then all of a sudden your milling will just stop. It generally speaking doesn't go catastrophically wrong in terms of ramming the bit into the bed or anything. It just reaches a line of G-code and it just stops. And then the only way I've found of reconnecting it is to do a hard reset or a power cycle of the controller, and then you lose all your coordinates and you don't know where you are, and it's just a right faff to get it all set up and working again, and then you don't know when it's going to fail next time. And to be honest, I can't live with that unreliability, or that lack of reliability. Now, I'm an electronics engineer by trade, so I've tried a lot of different techniques to mitigate this problem. I've tried usual EMC chokes. I've tried USB ground isolation dongle, lots of different things. It's difficult to pin down exactly what's causing it, but it's definitely EMC related. And to be honest, the things I've tried have made a massive difference. I mean, they've really improved it. I mean, when I first tried it was dropping out all the time, and then, now it very occasionally drops out. But again, I can't predict when that's going to happen. And if I've got sort of an expensive piece of wood on the table, and I'm ready to mill it, and it's going to take it sort of 3 or 4 hours, I can't have it dropping out, and then trying to figure out where I am from a coordinate system point of view after I've turned everything off and turned it back on again. It's just not acceptable. So anyway, going back, so that's the problem. So going back to the Sable, which is why it's here. The Sable was supplied with a controller, not surprisingly, but it's old school. It's a parallel port controller. By that I mean it uses a standard DB25 parallel port connection, a printer port connection, back to the PC, which to all intents and purposes in this context is general purpose I/O. It's just pins that you can switch on and off and back up and down, or pulse, or whatever you want to do with them. And that parallel port controller is specifically designed to interface back to the PC running MACH3 control software. Now MACH3 control software has been around since the ARC, the sort of dawn of time. It's decades it's been around, and its associated parallel port printer driver, which does all the clever interrupt based timing. The upshot is, you connect the parallel port to MACH3 and away you go. But the thing about that parallel port interface is, in my experience, having done tens and tens of hours of milling on the Sable, it is completely rock solid. I've never had it fail. I've never had it lock up, never had it disconnect. It just works, and so does MACH3. So the software's stable, and more importantly, or as importantly, the physical interface between the controller and the PC is rock solid and very immune to EMC, or appears to be. So that's kind of what I was going to do. I was going to replace the Arduino USB based controller with a parallel port. And so I'll show you the board I've got. So this is the board I'm planning on replacing the USB connection with. So this has been sourced, not surprisingly, from China. and it's a really nice board. It's but conceptually it's very similar to the Arduino based platform. If you as we said before, the Arduino is basically turning G code into a bunch of GPIO signals, direction, input, outputs, and returning limit switch positions or settings or states. This is doing the same thing, but you've got a parallel port here, standard 25-way parallel port, which is basically providing that GPIO. So instead of a little microprocessor board doing it, the PC's doing it, and the MACH3 parallel port driver is providing that intelligence rather than the Arduino platform. There's no microprocessor on this board. This is completely dumb. There's no software running on this board. It's just levels and signals coming in here, going over some optical isolation, which is just a good idea from a noise immunity point of view and also from a safety point of view, onto the stepper motor drivers, which are in here. There's a bunch of dip switches to set the micro stepping of the bipolar motor drivers and their maximum current limit to the motors, depending on what motors you're using. Again, this board's using the ever popular TB6600 stepper motor drivers. There's 4 of them under here with a little fan on the top of the heatsink. And then we've got the connectors at the back here. We've got power, X, Y, Z, and the 4th A-axis. This is a 4-axis controller. There's another connector on here which gives you PWM output if you want to use active spindle speed control. You've got a little connector here which is your limit switch or home switch or whatever you want to use inputs. There's nice little touches, 2 little relays on the board. One is being used at the moment could be used to turn your spindle on and off. I wouldn't advise switching a spindle with that little relay at mains, but you could use an external mechanical relay or a solid state relay using that as the slave. And then the other one could be used for, say, turning your coolant on and off if you're running coolant. There's another connector here which would allow you, if you wanted, to connect microprocessor control here. So you could, if you wanted, take the Arduino board and hook it in here, and that would work. This gives you, access to all the control signals to do what you want with. If you wanted to control them from some sort of single board microprocessor, I'm not sure why you'd do it, but you could. I decided not to rip this apart and steal the power supply out of it, so I'm leaving that intact. And I've just bought another switch mode power supply which came up cheap on Fleabay which is even more ridiculous than the other one, which is sort of 16 amps or something at 24 volts, 400 watt supply, which is a massive overkill for the motors on this WorkBee, but nevertheless, there it is. Now, the only thing I was a little bit concerned about, well, not concerned, was that, when you buy a board like that out of China, with all due respect to Chinese suppliers, you don't always get the best information. Sometimes you get none, or it's meaningless or wrong. But in this particular case, that wasn't true. So I emailed the Chinese supplier, and they sent me the link to an excellent PDF-based manual, which I've then subsequently printed out. Ta-da! So I won't bore you with all the details of this manual, but suffice to say, it covers everything you'd need to know about how to set this board up. All the physical and mechanical connections, dip switches, all the rest of the gubbins. There's, everything's here to get you going. Now, as I said before, these parallel port boards are really designed to hook back into MACH3, and this manual not only gives you a board breakdown from a the board description, but there's also several detailed pages on how to set up MACH3 to drive the board. Now, all this looks very, very similar to the information, or actually this is better than the information I got with the Sable2 2015. So I was really familiar with it. I mean, it's all very similar. The pins are pretty much standardized. It's pretty easy to set up, and MACH3 is pretty easy to set up. It's a very feature-rich and potentially complicated program, but it's not difficult to use, depending on what you want to do with it, like anything else. So let me think. Now, I did look at other controllers. I mean, there's plenty of controllers on the market. I mean, we all know who they are and what they are, and a lot of them come with Wi-Fi, Ethernet, USB, or combinations of those interfaces. And I did look at those. In my opinion, they are a little over-engineered and overpriced for what you actually want to do. I mean, all you're trying to do is just send some basic information from a PC to a controller to control some motors. You know, I don't understand the point of Wi-Fi. I mean, probably some people will now shoot me down in flames for saying that, but I don't understand the point of Wi-Fi. My PC, which is over my shoulder, is sat 2 feet from my CNC machine. I would never set a job off without being next to the machine. I've got to set the machine up to start the job in the first place. So then I would never set a job off remotely. So I don't know why I need a Wi-Fi connection. I mean, I work in radio for a living. I have done all my working life, and in this context, it's not going to be very reliable, or potentially not very reliable, especially when it's competing with your Wi-Fi, you know, the existing Wi-Fi network. So I don't get it. I mean, it might be useful for, say, you know, a hand or a neat feature for a handheld jog control, but you know, it's not something I would go down the Wi-Fi route just to have a handheld jog control. I just use a cabled one. For Ethernet, yeah, okay, I can see how Ethernet would work, but then you've got to hook it into your home network, and all the possible contention problems that might cause. And ultimately, you're using a piece of wire, and Ethernet's a piece of wire. It's a physical interface. If I'm going to use an Ethernet cable, why not just use a parallel cable? What's the advantage? You don't need the speed. None of these interfaces, none of this is speed limited. You know, so that's not, and I can't see a reason for doing it. And I can say I've had so many problems with USB. I'm certainly not going to go down that route again. And again, it doesn't give me any advantages. It's still a physical cabled connection. So so the upshot is, and you know, some of these high-end controllers are very expensive. I mean, they're hundreds of pounds, and that's for a board with no stepper controllers. You still got to then buy the stepper controllers on top of that. The advantage of these or this particular this parallel port board that I've just bought was less than £40 sterling UK money, you know, less than 40 quid. So now there's two issues with the parallel port approach. The first argument I've heard or seen a lot of people saying is, oh, well, you can't buy a modern PC off the shelf with a parallel port, and that's absolutely true. If you could walk into a high street store and buy a PC, it will not have a parallel port. But for the price of a couple of pints of beer and a packet of crisps, you can buy a PCIe dual parallel port expander for a PC, which will give you two parallel ports, 25 separate 25-way D connectors, and two separate address spaces. Now MACH3 will allow you to generate pretty much as many machine profiles as you want, and you can have two different machine profiles with all the different settings that those two machines need, including two separate parallel ports in two different address spaces. So you're using one piece of control software for multiple machines, which seems to make sense to me. Rather than what I've got at the moment, which is sort of universal G-code sender for one machine, which is dodgy and unreliable, and then MACH3 for the other machine, which is rock solid. I'd want to use the same control for both machines. So now the other problem is MACH3 is not free. It's, you know, you do have to pay for it. I can't remember exactly how much it costs. I seem to remember you can buy it for about £120 or something like that, which is quite a lot of money for a piece of software, especially an old piece of software. But the way I look at it is that the control board is only 40 quid, so you can still buy the control board and buy MACH3, have a completely feature-rich control software which has got a solid interface, and still save money over buying, say, a high-end Wi-Fi Ethernet based controller, which might prove to be unreliable. So that's the way I kind of looked at it. And I like MACH3. I like the interface because the interface is completely malleable. I mean, they call them screen sets. I mean, you can buy or download for free or build yourself a screen set to bolt into MACH3. You can write your own Visual Basic programs. It's extremely flexible. If you really want to get into the nitty gritty of it, you can do pretty much anything you want with it. I mean, I don't use the standard MACH3 interface panel because it's got stuff on it I didn't need. So I ended up buying for $10 or something a really nice simplified MACH3 front end interface, which has some of the features I don't need stripped out, but all the features I do need still there. And if I wanted to add another feature, and I could add one in myself. So anyway, that's the bottom line anyway. So I'll probably get a load of comments saying, oh, you're taking a backward step. But as I say, for me, the thing that's of paramount importance, more important than any one feature on any bit of control software, is the interface reliability. If that interface between the control software, the host PC and the controller, if that is not rock solid and has a tendency to disconnect or drop out, then all bets are off as far as I'm concerned. And I wouldn't mind dropping features and stepping back in time slightly with a parallel interface to maintain that reliability. So that's my 2 pence worth. Anyway, I'll do another little video once I've sort of got it all wired up, and then I can sort of demonstrate a little bit, using one machine in the other and how easy it is to switch between the two. Yeah, so anyway, thanks for watching, and yeah, comments more than welcome as long as they're civil. And I'll be back soon. Take care, and thanks for watching. Okay guys, Dave here. This is just a really short little bit of video here, just to show the board all wired up. It's not exactly spectator sport to show it being wired, so I've basically completed it and just given a quick video. So yeah, so the board here is mounted on a little panel directly above the switch mode power supply on some spacers, as I showed before. I've now got my WorkBee wired in, power here on the left hand side, and then I've got X, and then Y motor 1, Z, and then Y motor 2. Y motor 2 being wired into the A axis, which is slaved off the Y axis in MACH3. There's these three blue cables at the top. I don't know if you can just about see them, and there are 3 blue cables at the top, just kind of coming in here on the left hand side. Those are the limit switches. So I've got one on X, one on Y, and one on Z. They come along the side of the board here. And they're wired into this connector on the side. Just I don't know if you can see that very well, but they're wired into this connector. There's a 4th input which is used, which is going to be very difficult to see, but there's a two wire connection coming into input number 4, which is the Z probe input, so I can do auto Z probing. And that's pretty much it, really. I mean, it was oh, and then there at the bottom is the printer interface back to the PC. So I mean, it was like 10 minutes to wire it up, 20 minutes maybe, and then just some cable ties. Mains cables also coming in here with the rest of the cables. Again, because this is MACH3, you haven't got to worry about EMC or noise or running mains cables next to things, because the interface is rock solid and you just don't get any issues with running mains cables. The mains supply from my spindle is wired next to all of this stuff, and it causes no trouble at all. So anyway, there we go. I'll probably do another little video in a minute of it sort of up and running. Okay, cheers. Hello again, Dave here. Right, well, I'm kind of all set up and running here. I've got so many things to witter on about. I kind of don't know where to start, really. So let me just very quickly recap. So I did an initial video on the controller that I was planning on replacing my existing USB controller with. So I had a X-carve USB based controller which was giving me all sorts of USB based dropout issues. I've replaced that with a parallel port based controller hooked to MACH3. So I've got two machines here. I've got my trusty Sable2015 and my 1 meter square WorkBee. The previous little video I did just showed the board, the parallel port board that I was going to use on the WorkBee. So that's all of the hooked up, as the video showed, sitting sort of just over here behind me is the parallel port for the WorkBee. So I've got two parallel port based controllers, one for the Sable, one for the WorkBee. Both are hooked to a parallel port board in my PC, which supports two separate parallel ports in two mutually exclusive address spaces. So from MACH3's point of view, I've got one profile for the WorkBee, one profile for the Sable, which I showed the little chooser, you can choose between them, and MACH3 just has the two parallel ports configured differently in its two profiles. It's so simple to set up. It's really easy. So there's that. There's two controllers and the two. Now the other thing, having wittered on about not liking wireless, which I don't not like wireless. It's my bread and butter, is what I kind of do for a living, so I do like wireless. I just didn't want my primary. I didn't see the point in having my primary control for the CNCs going over wireless because of the proximity of all the equipment. It just seemed like an unnecessary risk, and I also didn't quite see the point of using Ethernet because it's cabled, and if it's cabled, then why not just use a parallel cable, which is, I've gone on about this before. People are going to disagree. Okay. So having said that, I've picked up one of these little bad boys. This is a wireless pendant or hand controller or shuttle, whatever you want to call it. It wasn't. I think I paid about £90 for it, which I have to say I thought was quite cheap. It's really nicely made. It's very solid. It's in this sort of ruggedized plastic rubber case, which is very. It's also magnetic. I haven't used this magnetic feature. You can stick it to things. It also comes with a little bracket, which I've got here on the bench, so you can kind of hook it up. So basically, what is it? Well, it's a way of wirelessly controlling pretty much everything you want on the CNC. And if the buttons don't do what you want, then there's a really nice little configuration graphical user interface, or GUI, which pops up in MACH3. Presumably pops up in other control software as well. And you can customize all these buttons. So I mean, I've customized some of them and changed their functionality. So you've got like a really nice little tactile jog control wheel on the front here, and then you've got basically an on-off button. This is battery operated, obviously, because it's wireless. So yeah, there's an on-off switch. It only takes a couple of AA batteries, probably lasts forever. There's a switch here which controls which axis you're currently talking to, and there's another switch here which controls which rate you are, which rate you want to employ for the movement. Then there's a whole bunch of buttons. I'll quickly spin through them. I mean, there's reset, so you can take the unit in and out of reset. Stop, start for your G code. Feed rate plus minus, spindle speed plus minus, machine home, safe Z, work home, spindle on and off, probe Z, and then you can customize them all. And each button's got two functions. So you can either press it and get the function, or you can press the function key and get it. So each button's got two functions which you can customize. It's pretty cool, actually. I didn't think I wasn't sure whether I was going to like it. But I thought for the money, it was worth a punt. But I do really like it. And then on the display up here, you've got your X, Y, and Z coordinates, machine coordinates. That is, sorry, rubbish. Work coordinates, which currently is showing 0, 0, 0, whether you're in what state you're in, reset or sort of running continuous or step mode, and battery life, and RF link status, which I'm not sure what sort of RF link it's using. I don't think it's Bluetooth. It's probably some sort of proprietary thing. Doesn't really matter. I don't know what the range is. It works across my workshop. I haven't tried it any further than that. I wouldn't be controlling the machine too far away anyway. So there we go. So probably the easiest way to demonstrate this thing is to actually sort of use it. So at the moment everything's in reset. I've selected the Sable as the machine I'm currently talking to. So you probably won't be able to hear this, but if I press the reset button on here, which will take the MACH3 out of reset mode, then yeah, I can hear the motors making a faint whining noise from the Sable, which basically means that they're now being supplied with holding current. So the whole thing's up and running. So I've currently got the X-axis selected, so if I spin the little wheel, then the machine will move, hopefully. There you go. So it's in a continuous mode, so if you keep rotating, as soon as you stop, machine stops. Rotate the other way. So much fun. And stop. So if I then select the Y-axis, and the Z-axis, there's also a step mode where you can set up how far you want it to move, and then you just hit the dial one way or the other and it'll move that distance. So now I've moved it according to the readout here. Mine is approximately X minus 49, Y minus 14, Z 17, which is what it says on MACH3. You should be able to see the MACH3 screen in the top right hand of this video. So one of the buttons I've configured, well, it was already configured, but one of the buttons that on here, I'll move that back to X. If I press the work home button, it dutifully has work homed. There's not much else I can show you on the Sable because there's no limit. I haven't got any limit switches or anything like that. It's too small a bed. It's not worth the hassle. You know, I don't have a concept of machine coordinates on the Sable, although obviously there are. Because it's such a small bed, I just move it to where I want, 0 the X, Y, Z, and get on with it. So I've actually got some code just as a little demo. So I've got some code loaded up on the MACH3 there, right? So one of the other features, you can stop and start from the Shuttle. So there's a green button here which start, and a little sort of play arrow if you want. So if I hit that, there we go. Don't know if you. So it'll start running the job. Don't know if you can hear or see that. It's quite a small job. It's actually a little coaster which I've been milling in brass. So it's not exactly moving very much, but you should be able to hear the motors doing their thing. So I can also at any point stop that by pressing stop. And then if I press work home, back home again. What I'll do is I haven't got a button actually set up to rewind the code, so bear with me. Right, so that's rewound the code. Okay, so there we go. Oh, sorry, I didn't actually mention what this was called. Its catchy little name is a WHB04B-4. So you can pick them up. They're all over eBay. I got mine I bought this one this came from Germany, which bizarrely was actually cheaper than buying it direct from China, by about £10. So and it came DHL, really well packed, really nice. Comes with a disc which has got all the macros for MACH3, and also a DLL for MACH3. So maybe this is only for MACH3, maybe. What else can I mention while I'm here? Anybody that's used MACH3 or familiar with it, has probably noticed that I'm not using the standard screen, the standard MACH3 screen. I found that a little bit cluttered, and I had stuff on it that I didn't really need. So for, I think it was $10 or $20, I can't remember which, I bought a screen set from Mr. Jerry Gradinsky. Hopefully I pronounced that right, Jerry Gradinsky. Excellent screen set, really nice, excellent manual, and so that's the screen set I tend to use, because it's got everything on it that I need, and nothing really that I don't. So and it's been rock solid and, you know, really nice to use. So that's my sort of MACH3 screen set. So what I'll do now is I'll stop this video, and then I'll fire up MACH3 using for the WorkBee. So that's just a matter of killing the MACH3 and then opening the profile selector, selecting the WorkBee, and then re-invoking it, and then it'll come up with the WorkBee. Okay, so back in a minute. Cheers. Okay guys, back again. Right, so what I've done is I've simply just closed MACH3 down, and then used the chooser to choose the WorkBee profile, and then MACH3 then dutifully re-invoked. I've set up, in terms of the shuttle, because they're two separate profiles, one for the WorkBee, one for the Sable. If you customize the buttons, you either have to do it twice, once in each profile, or you could copy over the profile from the setup file from one profile to another. It was so easy to set the buttons up, I just did it twice. So now we're now hooked into the WorkBee, hopefully. So as I say, if I now hit the reset button, I can hear the WorkBee motors have just come to life. Now, so if I move the jog dial, now we're set to 100% on the x-axis. Select the y-axis. And then if I hit work home again. Now the only thing, this is probably just me and my brain, or lack of it, the only thing I found a little bit confusing with this thing is nothing to do with the design of this. This is a jog wheel, yeah? So if I select the x-axis, I mean, normally if I was to use a keyboard, then I'd have left, right arrow, right arrow, back arrow, front arrow, and I've got my keyboard set up so that if I hit the left arrow, then the head moves left, or the spindle moves left. Hit the right arrow and it moves right. Well, that's the same here. So basically, you can't see it in this video, but on the top of this jog wheel, there's an arrow pointing to the right with plus, and an arrow pointing to the left with minus. So I've got it set to the x-axis. If I move it clockwise, as if I was looking at it, then my spindle moves right, producing a positive offset. And spin the other way. There we go. If I it gets a little bit more, well, I found it gets a bit more confusing when you do the y-axis. Now, when you hit plus on the y-axis, I mean, depending on how you got your machine set up, you know, which I know is maybe obvious, but it wasn't completely obvious to me all the time, which way the spindle's going to move. So what I've done, and people are going to laugh, is on the front of my spoiler board here, I've written minus in this corner and that corner. So I know that if I move this jog wheel in the minus direction, spindle's going to move towards me. Et voila. Hang on. Sorry, press the wrong button there. So I've moved it back. So now, probably more importantly, actually, is which direction the spindle's going to move. So if I move it to the Z-axis, now, again, people are going to laugh, but I've written I'd rather be safe than sorry. I've written a plus on the top of my my X-axis here, Z-axis, sorry, on top of my Z-axis. So I know if I move my encoder in the plus direction, the spindle moves up. Like that. It's just, you know, sometimes it's you're thinking of other things. You spin this the wrong way, and then you'd end up crashing your bit into the workpiece or something. So it's just So I've just added a bit of annotation so that at least if I, you know, rather than second guessing, I've just got to, I think, right, plus at the top, spin this clockwise, it's going to go up, not down. Stupid, but there we go. So what else have I got set up here? So rather than my limit switches, which I've set all the limit switches up, other than my limit switches, I've got my Z probe set up. I don't know if you can see that. I've got my little Z, just a little piece of aluminium which is about 5.8 mil thick. Yeah. And then that's plugged into. So I've got a crocodile clip on the tool. This is a really nice bit for engraving, and that I've made a little bracket up here, and there's a connector that plugs in the Z probe. So, and I've set up a hotkey on the controller. Well, it's not actually set up, it was called Probe Z, so it was a pretty good indication of what was going to happen. Sorry if you can hear the rain, it's hammering down on the workshop. So if I press Probe Z, voila. So now if I move the touch plate and hit Work Home, perfect. I doubt you get a sheet of paper under that. So if I now move to Z and then double checking my plus sign, move, because I don't want to ram that bit into the table. If I move it in direction plus, off it goes. Now I suppose what else can I show you? Let me just remove this a minute. And the crocodile clip. So because I've got my limit switches set up, basically I say I've been the button I've been pressing to get it to home is the work home button. But if I press the machine home button, might take away. I don't get the machine moving too fast. I mean, you know, it's not gonna take a minute or two, not even a minute. Get in there. There, excellent. So if we look at the MACH3, it's now reporting up here a machine home of 000. So if I just you get bored of this, aren't you? Just moving the X-axis to the left with the little controller. Well, you can still use the keyboard, and you don't have to sit there spinning this little thing like a lunatic. Select the Y-axis, and then well, I'll just stop it there, and then basically if I zero the you can also set a button up, by the way, to do. I mean, I'm zeroing it on the on MACH3 using the mouse, but you can zero it with a preset button on this. I just haven't set that up yet. So if I zero all this, so I've now got a work home of 0. If I press start, it's now running the job. Stop that. Work home it. Oh, the other thing I've set up on here, you probably won't be able to hear this, but I don't have a spindle power control at the moment, although I'm going to set that up. But if I, on here, I don't know if you can hear that, there's a relay. The relay switching on and off the on the board. So on the machine home it again. That's pretty much the size of it, really. So everything seems to be working perfectly okay. I've not had any problems, not had any outages at all. But then because it's MACH3 over a parallel port, I did expect to get any outages. And it's all worked perfectly. And now because the rain is absolutely hammering down, I'm going to call it a day. Anyway, well, thanks for watching. Any comments or anything anybody wants to know, or any more information, then yeah, just give me a shout. And hopefully any second now it's homed. Okay, cheers. Thanks a lot. Bye.